useful for calculating the Z transforms in the various problems. First one, xn equal to, though we have already seen this, we'll take it once again. In this we'll cover all the various common Z transform pairs. These Z transform pairs should be known and these should be remembered at the time of solving the problems. Okay. Second one. Okay. One minus AZ inverse ROC is mod Z greater than mod A. Fourth one is minus n minus 1. Difference here is this is causal, this is anti-causal. Xz here is same 1 upon 1 minus AZ inverse. ROC in this case is mod Z lesser than mod A. Okay. Xn equal to cos omega naught n un. For this we have to find the Z transform, but before finding Z transform I just write the equation for the Z transform for this. This is equal to 1 minus Z inverse cos omega naught upon 1 minus 2Z inverse cos omega naught plus Z minus 2. ROC in this case is mod Z greater than 1. Okay. Now for finding the Z transform of cos omega naught n, I can write xn equal to cos omega naught n un in terms of exponential components 1 by 2 e to the power j omega naught n un plus 1 by 2 e to the power minus j omega naught n un. Okay. So xz is nothing but 1 upon 1 minus 1 by 2 outside e to the power j omega naught n z minus 1 plus 1 upon 1 minus e to the power minus j omega naught n j omega naught z minus 1. Okay. ROC in this case mod z greater than 1. ROC in this case mod z greater than 1. Thus the overall ROC will be also mod z greater than 1. Okay. Now this I can expand this and can write this 1 minus Z inverse cos omega naught upon 1 minus 2Z inverse cos omega naught plus Z minus 2. Okay. So this is the way which we can find the Z transform of cos omega naught. Important is to write it in this form and then finding a Z transform of this and Z transform of this and solving it further, we will get this relationship. Okay. Similarly, I can find Z transform for xn equal to sine omega naught n un. Okay. For this, I'll write first the Z transform, which is equal to Z inverse sine omega naught upon 1 minus 2Z inverse cos omega naught plus Z minus 2. Here also mod Z is greater than 1. Okay. So this is a case. We will solve for this also. The solution is, the way of solving for finding Z transform of sine omega naught un is again same. I can write it as 1 by 2j e to the power j omega naught n un minus e to the power minus j omega naught n un. Okay. Solving this, Z transform for this, I will get 2j 1 upon 1 minus e to the power j omega naught Z minus 1 minus 1 upon 1 minus e to the power minus j omega naught Z minus 1. Okay. Solving it further, it will get the Z inverse sine omega naught upon 1 minus 2Z inverse cos omega naught plus Z minus 2. ROC will be mod Z greater than 1. Okay. So these are the few important Z transform pairs which we by heart, and the time of solving the problems, these will be helpful. Now we will see the properties of the Z transform. These properties of the Z transform will help in solving the many problems related to Z transform. Okay. The first property. The first property is linearity property. This property says that if x1 has got the Z transform as x1z, x2n has got the Z transform as capital X2z, then a x1n plus b x2n gives me the Z transform as a x1z plus b x2z. Okay. This property this property has got the two basic theorems related to this. First one is the principle of superposition. Second one is principle of homogeneity. So linearity property, if it satisfies, that means it is satisfying the two principles, the principle of superposition as well as the principle of homogeneity. Then what about the ROC of this? We have seen that Z transform if has got the different ROCs, the Z transform will have a different ROC. Okay. As per the ROC is concerned, suppose this particular thing has got ROC R1, this particular Z transform has got the ROC R2, then AX1Z plus BX2Z will have the ROC R1 intersection R2 at least. Okay. Note, in this, if there is a pole zero cancellation occurs, then the ROC will not be the intersected ROC, but it will be something different ROC. We have to find that ROC depending on how the pole zero cancellation has taken place. Okay, just write down. If pole zero cancellation takes place, then ROC will not be R1 intersection R2. Okay. Next property in this is time shifting. If Xn has got the Z transform as Xz, then X of n minus k will have a Z transform Z to the power minus k Xz. X of n plus k will have Z transform as Z to the power plus k Xz. Okay. If we talk about the ROC change in this case, then ROC of Z minus k Xz will be same as ROC of Xz. The only difference will lie here. It will not contain Z equal to 0 if k is greater than 0 and Z equal to infinity if k lesser than 0. Only these two things will not be there, otherwise the ROC will remain same. Okay. Next, third property in this is scaling in Z domain. Z domain scaling means we are multiplying by some coefficient at the in Z of the Xz. That is, if Xn is Xz, then X of A inverse Z or X of Z by A will be equal to A to the power n Xn. How the ROC will change? Suppose the ROC for this R2, then ROC in this case will be okay. So ROC will also change by the same constant, same scaling factor by which we are changing the Z. This is an important point. Based on this, find, based on the above scaling in Z domain, let's do one problem. If xn is equal to a to the power n cos omega naught n un, then xz is question mark. Find xz. Okay. Okay. Using the above property, we know if xn is equal to cos omega naught n un, then xz is equal to 1 minus z inverse cos omega naught upon 1 minus 2z inverse cos omega naught plus z minus 2. Okay. Now, when an is multiplied here, that means scaling is done in z domain by 1 by a. So, replacing z by a inverse z, we get x dash z is equals to 1 minus a z inverse cos omega naught upon 1 minus 2a z inverse cos omega naught plus a square z minus 2. Okay, so this is a way of solving the problem. So we can make use of the above mentioned property, which is this, for finally getting the z transform for this. Next property is time reversal. Okay, if xn z transform is xz, assuming ROC is R1, R2, then x of minus n will have z transform x of z minus 1. ROC will be 1 by R2 mod z 1 by R1. If we see the proof of this, it is simple. We can write it as like this. Z transform of x of minus n is summation n tending to minus infinity to infinity x of minus n z to the power minus n. Okay, so I can write it as like this. Summation m tending to minus infinity to infinity x of m z to the power minus 1 minus n. So this is nothing but x of z minus 1. So we have seen z has changed from z to 1 by z. So ROC will also become reciprocal of previous ROC. Okay. Now, fifth property will be differentiation in z domain. Of course, since time domain is discrete, we cannot differentiate that. We can differentiate but in x domain. If xn is called z transform as xz, then nxn will have z transform as minus z d by dz xz. Okay, so this is a relationship which is there between the differentiated Z transform with the time domain signal. Okay, ROC will not change. This is a note. Okay, based on this, you will see two problems for differentiating signal. Sorry, for differentiating Z transform, how the effect will be there on the time domain signal. Find Z transform of Xn, where Xn is given by N, An, Un. Okay. X1n, suppose it is like this, An, Un, then X1z can be written as 1 upon 1 minus Az inverse ROC mod Z greater than mod A. Okay. Now, d by dz X1z multiplied by minus Z can be written as Az inverse upon 1 minus Az inverse whole square ROC mod Z greater than mod A. But nxn will have Z transform as minus Z d by dz xz. Thus, n an un will have Z transform as Az inverse upon 1 minus Az inverse whole square. Okay, ROC in this case will be mod Z greater than mod A. Next is convolution property. If there are two sequences x1n having Z transform as x1z, x2n having Z transform as x2z, then the overall sequence xn, which is nothing but the convolution of two sequences x1n convolved with x2n, will have a Z transform xz is equals to x1z multiplied by x2z. Okay, so this is a way the convolution in time domain goes to multiplication in Z domain. Write down, remember this point, convolution in time domain converts to multiplication in Z domain. Very important point. Based on this property, we can solve certain problems regarding the convolution. Okay. Based on this convolution property, see this problem. X1n is given as 1 minus 1 1. X2n is given as 1 0 1 0. Okay. 0th point of this is here, 0th point of this is here. Then x1n convolved with x2n is equal to question mark. We have to find this value. Okay. So solution using Z transform. I have x1z as 1 minus Z inverse plus Z minus 2. I have x2z as 1 plus z minus 2, okay, then overall z transform xz is equals to x1z dot x2z, which is equals to 1 minus z minus 1 plus z minus 2, 1 plus z minus 2. So I will get 1 plus z minus 2 minus z minus 1 minus z minus 3 plus z minus 2 plus z minus 4, which is equals to 1 minus z minus 1 plus 2z minus 2 minus z minus 3 plus z minus 4. Xn, which is equals to convolution of x1, x2n, will have z transform as xz. This is equal to 1 minus 1, 2 minus 1 and 1. 0th point of the slice here. So in this way we can find the convolution of these two sequences. Okay. So this is a way we should know and we should remember for finding the convolution. This is the easiest way. A similar thing goes reverse way also. If we do the convolution in z domain, then it will goes to multiplication in time domain. Just write a note. Convolution in z domain goes to multiplication in time domain. Okay. One more theorem left in this is initial value theorem. Initial value theorem says that if xn is causal, then x0 is equals to limit z tending to infinity xz. This will also help in solving the various problems.